Hey everyone and welcome back to Prefusion. So today we'll be solving the engineering mathematics solutions of K 2024 from the W branch. So let's start. This is the first question. So in the first question they have asked us to find the sum of the eigenvalues of this matrix, like the square of this. So you can proceed in two ways. I will tell you the both ways. Okay. So first method is simple. Just do the matrix multiplication, and what is the sum of eigenvalues? It is the trace of my matrix. So simply just square this, then just find the trace, and that will be your answer. Okay, and most of you will do like that also, and that is fine, totally fine. So first we have to square this. 1 2 3 4 1 2 3 4 equals to 1 plus 2 times 3, which is 6. Now this 2 plus 8, and this 3 plus 12, 6 plus 16. Okay, so this is 7, 10 and 15 and 22. So what will be your trace? So like sum of eigenvalues will be simply equals to trace a square, so which is 29 in this case. Okay, so this is your answer, you're done. So how else you could have done it? You could have done simply this thing, that you have to find the sum of the eigenvalues. So what will be my sum of eigenvalues? So so what are my new eigenvalues basically? So if my new previous eigenvalues were lambda 1, lambda 2, eigenvalues of a, then eigenvalues of a square would be simply lambda 1 square and lambda 2 square. So how to find them? Like what will the sum then? Here the sum will be lambda 1 plus lambda 2. Here the sum will be lambda 1 square plus lambda 2 square. Now we have to, from here we have to get to here. How do we get? So what we can, like, we know this value. What is this? This is a trace of this a itself, which is 5 in this case. So this will be 5. Now we can simply use this relation, that lambda 1 plus lambda 2 whole square minus 2 lambda 1 lambda 2 will be equals to, if you don't want to square this, okay, if you don't want to square this, if let's say if it is a if you don't want to compute, you can do it like that also, do it like this also, because this may come in handy in some other question. This will be equals to lambda 1 square plus lambda 2 square. Okay, now this is what, this is 5, this is what, lambda 1 lambda 2, this is the product of the eigenvalues, which means the determinant, which is 4 minus 6, which is minus 2. So this will be 5 square minus 2 into minus 2, which is equals to lambda 1 square plus lambda 2 square. So this is 29. This is my answer. Okay, like this also you can do. So whichever you find suitable, you can follow that. 29. So next question is from probability distribution. So like this, you can take it under random variable as well, but let's do this. This is a good probability question as well. So they have told us that x is a random variable which is uniformly distributed from minus 10 to plus 10, and 0 is also included. Do remember that. Okay, then which of the following state is or are uniformly distributed random variable? Now x is a uniformly distributed random variable. Now if we do some modifications with x, which of this will remain random variable and which of this won't remain random variable? Now what was the definition of random variable? Sorry, not sorry, I meant which of this will remain uniformly distributed random variable. Okay, so what is the definition of random variable, uniformly distributed random variable? The definition is the probability at each, now these are discrete variables, so the probability at each discrete points should be same. That's why it is told as uniformly distributed. If you recall the graph of uniformly distributed, here in this case, as it is discrete, it is not continuous, it will be something like this. Okay, probability in each points. Okay, probability in each point, this is the f of x and this is x. So in each, like let's say minus 10 plus 10, as is uniformly distributed, this will be what? This will be what? Total. What is the total? Total probability will be 1. Okay, summation of all of those. Okay, and how many each has f of x probability, let's say p of x probability or p probability into what? Total number of these variables, total number of variables. So how many total I have? I have 20. No, like don't skip this 0 as well. Okay, so this will be what you can do is simply, what I used to do is 10 minus maximum minus minima, okay, lower range minus minima plus 1. This will always work out 21. Okay, you get, like, if you have to find the number of variables, like number of boxes between two ranges or something, number of this between a range, how many number of elements are present, so you do maximum minus minima plus 1. So this is 10 minus 10 minus minus 10 plus 1, 21. Okay, so this will be 21. So my p will be 1 by 21. So this is a starting case. So here obviously it is uniformly distributed, so this will be true. Now let's solve it for the 4 options here. So when we are doing x cube, so if we are doing x cube, what does that mean? If we are doing x cube, that means minus 10 cube, so it is minus 1000, then minus 727. Okay, and this will be also something minus, and then I'm sorry, this is 9, not minus 7, this is minus 7 to 9. Am I correct? Okay, yeah, this is minus 7 to 9, and this will go on. Okay, all of them will be different, all of them will be distinct. So this will go on, and here we'll get 1000, sorry, not 1000, 7 to 9. All of them will be distinct, all of them variables will be distinct, and this will be 1000. Okay, so yeah, this is satisfying everything. Let me just check quickly if it is recording or not. Yeah, this recording, fine. So all of them are distinct. Okay, here also all of them need to be distinct, okay, to have the probability equal. Else one element could have probability more than the other elements, then it wouldn't have been a uniformly distributed random variable. Okay, so here all of them are distinct, all are distinct, hence here also my probability will be p by 21, hence this is correct, A is correct, it is uniformly distributed. Now let's go for the second B option, x minus 5 whole square. So how will each elements be? So x minus 5 whole square, so we're shifting everything by left towards 5, so this is 15 square, so this is 225. Okay, 225 will get shifted. Now what I want to put in attention is to this this 5 and onwards. So at 5 what will happen? It will be 0 square. Okay, fine. At 4 what will happen? It will be 4 minus at 1 what will happen? It will be minus 3 whole square. Sorry, what I'm saying, at 1 what will happen? It will be minus 4 whole square, so it will be 16. Okay, and at 2 what will happen? It will be 3 whole square. Okay, it will be 9, and again we'll go at 0 at 5 what will happen? It will be 0 whole square. So what we are seeing is these two are same, and a few other elements are also same. So if few other elements are also same, then what is the problem here? The problem is basically few elements have higher probability than few other elements, so probability of all the elements are not same. Like this 0 is coming twice, so total probability is 1, and how many number of zeros I have? 2, so 2 by total number of elements 21, which is like the probability of this coming to 0. Now probability of this to 225 is only 1, because I have only 1 to 25, and total number of elements is 21. So probability different. Okay, so hence like this is not a uniformly distributed random variable. Now let's go to the C option. Okay, you can check same. Now I can do this with just by saying mouth that x plus 10 whole square. Now if I do x plus 10 whole square, what will happen? 0 square plus 10 square, like this will be 0, this will be 1 square plus 2 square plus 3 square plus 4 square. Fine, this is fine, everything is distinct here, so this will be correct, this will be correct, this will be correct. Now what about this x square? Now x square won't be correct, because minus 10 whole square and 10 whole square are same, minus 9 whole square and 9 whole square will be same, 0 will be only distinct, others will be same. So these two won't be correct, these two won't be correct, and A and C will be correct. Okay, so now f of z equals to e raised to power z square plus cos z. Find the coefficient of z to the power 5 in Taylor series. Now, like if you recall correctly, like we can solve this using the Taylor series also. But if you recall correctly, that what power components will this e raised to power z square will contain? So like e raised to power ix can be expanded like this, 1 plus ix by 1 factorial plus ix whole square by 2 factorial. Okay, now if you expand the same way this will be 1 plus e raised to power not e raised to power z to the power square by 1 factorial plus z to the power square whole square by 2 factorial and so on. So this will always contain even powers. Also this cos, right, this cos also always contains even powers. If you break it down, e raised to power ix plus e raised to power minus ix divided by 2, if you break it down, it will always contain even powers. Okay, so what will happen, as f of z contains even powers only, hence the coefficient will be 0. So answer of this question is 0. Okay, so it will not contain any odd term. So here we have been given odd part, so like that also you can do, or you can do it from the basics, like I was doing it with the basic itself, but I did it bit quickly. Now this next question is, you have to like find which of these functions are analytic. So for checking analytic, we use the Cauchy-Riemann equation. So simply we use the CR equations. Okay, and you will be able to easily solve this. Now this first one is analytic, just by seeing this we can understand, because this is a polynomial, but still let's solve it. So your f of z is u plus iv. Okay, and for it to be analytic, which condition needs to be satisfied? Del u upon del x should be equals to del v upon del y. So the first ux should be equals to vy. Okay, that is very important. And then del u upon del y equals to minus del v upon del y. Okay, so del v upon del y equals minus this. Sorry, yeah, this is del v upon del x. Sorry, del v upon del x. Okay, so now let's like prove for each of them. So this one is easy only. So if you do it for the first one, okay, so f of z is given z square minus z. This is polynomial, so this will always be applicable, but still let's prove it. So this will be z. Now what is z? Z equals to x plus iy, x plus iy whole square minus x plus iy. Okay, so this is x square minus y square minus 2xy minus x minus iy. Okay, so this is correct. Now let's solve it. This will be ixy actually. X square minus y square, and this is minus x plus I 2xy minus sorry, this is minus y. Okay, so this we already know that property, but still I am doing it, minus y. So now let's use the Cauchy-Riemann equations. So first we have to find ux. What is ux? Ux is 2x minus 1. So this is my ux, u, and this is my v. Ux is 2x minus 1. What is v of y? V of y is minus 2x minus 1. Yeah, sorry, it will be actually a plus over here. I missed this plus. This will be a plus. This will be plus ixy, right? So this is plus. So this is also plus. Okay, so this will be plus. So yeah, ux equals to vy. Fine. Then let's find uy. Uy equals to minus 2y, and vy equals to this sorry, vx I have to find. Vx equals to this 2y. Okay, so yeah, they are negative with each other. Yes, so this is satisfying. So this is analytic. So A will be analytic. Anyways, from polynomial you can understand this is analytic. Let's do it for B. So from B, what you observe is this is only real component, like this f of z equals to e raised to power mod of z, which is equals to e raised to power under root x square plus y square. Okay, now like this has only real component, no imaginary component. This won't be analytic, but still let's check it. So here your ux is, first you have to solve it like this, 1 by 2 under root x square plus y square into e raised to power under root x square plus y square into, we have a 2x as well, okay, and uy is simply the opposite of this one. This will be, so not uy, sorry, vy will be 0, because we don't have anything. So definitely, like, from here you can say this is not analytic. So like from just seeing it we can understand, but still this is not analytic. Okay, now let's do for the third option. Third option is imaginary real of z. So real of z is x, like z equals to x plus iy. So real part of z is x, and so f of z equals to I x. Again, what we see u equals to 0. Again, this is not analytic. Again, let's do this third one. Third one will also be same, only because it will be imaginary part of z. Okay, imaginary part of z is y. Again, so d f of z will be imaginary part of z, which is y only. Again, what you see, like your v is 0. Okay, so again this also won't be a analytic function. Okay, so like the answer to this question will be A. Like very simple only, like just by seeing the polynomial you could have taken it and move to the straight to the next question. Okay, if this was an MSQ then things would be a bit different. Okay, so yeah, this is the question that I got. Now like let's solve this question. So what is this question? This question is simply you have to find the directional derivative along a vector, okay, of this function, like very standard question. So what is the value of the directional derivative? So directional derivative is simply equals to what? First you have to do the this del of f, okay, then you have to dot product with this u, and you have to dot product with the unit vector along this direction. So you have to divide by magnitude as well. Okay, and this is the value of the directional derivative of this f vector along that direction. Okay, so first let us find del of f in the particular point, which is, okay, sorry, I forgot to write the point. So from what I remember was the point along 1 comma 1 comma 1. I think this one was the point. So what you have to do is you have to do del of f. So del of f equals to, what you can do is simply write in terms of x, y and z. So first let me write in terms of x, y and z, then I will do. So this is 2 ln x plus 2 ln y. So this will be 5 ln x plus this is 3 ln y. I'm just doing it for my convenience, and this is 3 ln z, and this is ln z. So this is 4 ln z. So this will be delta. Now simply I can do the gradient of this. So this will be 5 1 x I cap plus 3 upon y j cap plus 4 upon z k cap. Okay, just to simplify things, and we have to put point equals to 1 comma 1 comma 1, x y z equals to 1 comma 1 comma 1. So it is 5 I cap plus 3 j cap plus 4 k cap. Okay, now dot this 2 I cap plus j cap plus 2 k cap divided by this 3. Okay, so this is 10 plus 3 plus 8 divided by 3, so this is 13, and 8 is like 21 by 3, this is 7. Okay, so this will be the answer, like pretty straightforward, nothing much tricks here. So next, you have been given a function which is like this, that it is a square of max of 0 comma x, fine, in the range between infinity to, sorry, this will be x, I think this will be x, minus infinity to positive infinity. Then which of the following is or are true? F of x is differentiable but f dash of x is not continuous. F of x is not differentiable but f dash of x is continuous. F of x and f dash of x both differentiable. So you have to talk about the differentiability and continuity. So let's first plot the function. Okay, you can solve it just by plotting the function, or like with the mathematical, like the definition of the function as well in terms of mathematical. So it is talking about the maximum of 0 comma x. So like before x less than 0, what will happen? X will be negative, like this will be negative, and this is still 0, and we have to choose the maximum. So we'll choose 0 obviously. So up until this 0 point, we'll choose 0, and 0 square will be 0 itself. And after this 0 point, what is happening? This is still remaining 0, and this is increasing linearly. Okay, so 1 2 3, it is more than this, so we'll choose x, and it is a linear function, so square of this will be something like this, parabolic. Okay, so this will be my f of x. Now what are they talking about? They are talking about the continuity and differentiability. So f of x is differentiable but f dash of x is not continuous. So for that, we have to plot the f dash of x also. You can do it with definitions also. I will do it with definitions also. So f dash of x. So f dash of x here is 0 anyways. The value of the function isn't changing, neither increasing nor decreasing. But here it is always increasing, So it is positive again. And it is linear, basically like x something x square. It will be 2x. So it will be linear. Okay. Linear. So f dash of x graph is this. Now what we are seeing is this is continuous because the value is not suddenly changing here, but we see a sharp change in the slope. Okay, sudden change in the direction. Okay, so here the slope was 0. Suddenly it is saying the slope will be this. Okay, so here we have change in the slope. So f dash of x is not differentiable, but f dash of x is continuous, and f of x is both continuous and differentiable because its differentiation, like differentiation of f of x is continuous. That is fine, but differentiation of this won't be continuous because we are suddenly seeing a sharp change in the tangent. Suddenly sharp change in the tangent, but there isn't any sudden jump. Okay, so it is continuous. So it is continuous but not differentiable. It is both continuous and differentiable. Okay, because we see that slope is not suddenly changing. Here slope is, it's saying slope is this, but this slope is 0 at this point. Okay, that's why. So you can see f of x is differentiable. Yes, it is differentiable. F dash of x is not continuous. No, it is continuous. So this statement is wrong. F of x is not differentiable, but f dash of x is continuous. Again, this is wrong because f of x is differentiable. F of x and f dash of x both differentiable. Now is this true? No. F of x is differentiable but f dash of x is not. I just told you, right? There is a certain change, sharp change in the slope. Here f dash of x is differentiable. Sorry, f of x is differentiable but f dash of x is continuous. Yes, this is true. F dash of x is continuous because here there isn't any sudden jump. Okay, this value isn't suddenly changing. It is continuous, and f of x is differentiable. Okay, like these statements are saying the same thing basically. If my f of x will be differentiable, then that means my f dash of x will be continuous. So just without even without even going the graphs, you can answer, you could have answered this question. But for all this, you have to check, like for the f dash of x, right? For f dash of x, you have to check. Okay, so but first, like for that, you have to obviously see if this is true, if one of them is true or not. If one of them is true, then definitely the other one will also be true. Like you have to check, still you have to check this option. So you have to draw the graphs. So like how to do it in the simple, that definition method. So my function can be defined like this. F of x will be simply defined in two ranges. It will be equals to 0 for x less than or equals to 0. We can say equal or not. It will equals to x for x greater than or equals to 0. So not x square. Okay, as it is square. Now you do the differentiation. Okay, you do the differentiation. This will still be 0. Now what do we see? At x equals to 0, this is continuous, because at x equals to 0 is also 0 and this is also 0. So left hand limit and right hand limit are same. So yeah, it is differentiable. Let's find the double derivative now. Find the double derivative. This is 0 still, less than 0. This is 2 now, greater than 0. So here we see a discontinuity. So the differentiation of this, like there is a discontinuity at x equal to 0. So at x equal to 0, this is saying no, this is 0, but this is saying no, it is 2. So there is a discontinuity, hence this function like f dash of x is not differentiable. Okay, so from here you can understand. Okay, so what is this next question telling us? So next question is very simple. You have to identify which of the following matrix is invertible. So for invertibility, the determinant should not be 0. Okay, now either what you can do, either you can make like the elements, two elements of one column like 0, and just with the remaining element you find a determinant, or you can find relations between the rows and columns. If there is some relation then between the rows or columns of that same matrix, then the determinant will be 0. So I'm not able to find like any relation here. Okay, but here what do I see? Try to eliminate the options. Here I see row 2 equals to row 1. So this will be eliminated because there is a relation and the determinant will be 0 and it will not be invertible. Okay, so inverse has to exist. Invertible means inverse has to exist. Now if I like this also has a relation between the rows. 3 times row 1 is equals to row 3. So this is also gone. Again this, so 0.5 times row 1 equals to row 3. So this is also gone. So only this one is remain. This will be answered, but let's cross verify. So you can simply find the determinant. Okay, you just do one thing. So you just make this element 0. So this will be 148 0 42 0 minus 2 minus 4 minus 4 0 minus 2 minus 4. Okay, yeah. So now you make the determinant, find the determinant. So this is 1 times 4 times minus 4 minus 2 times minus 2. So this is minus 16 minus 12. So yeah, this is not 0, hence this is invertible. So A will be my answer. So this was the last question basically. So yeah, I hope you liked the video. Then if you did, then do please hit the like button, and I will see you with some other videos. And please like suggest us something, like if you want more in what do you want currently, like the gate has happened, what things do you want from us? You can just put it down in the comments below or ask us in the Telegram group. So I'll see you in the next video. Thank you for watching.